Hello everyone, I am Himanshu from Department of Mechanical Engineering. Today I am here to give you a lecture on the subject non-destructive evaluation and testing. The subject code is ME419. We are studying in Unit 1, lecture number 4. Today's topic name is types of primary processing discontinuities, welding discontinuities and secondary processing discontinuities. We have studied previously about non-destructive techniques, destructive testing. Now we are studying about the various problems or discontinuities that the inspector should know or they have found out in the past experiences. Okay. Today's objective is to make students have a basic understanding of types of primary discontinuities, welding discontinuities, secondary processing discontinuities, and the various factors influencing them. And the today's outcome will be the students will have understanding of these all kinds of discontinuities like primary processing discontinuities, welding discontinuities, secondary processing discontinuities, and various factors influencing it. So primary processing discontinuities. This group refers to the discontinuities that originate during hot or cold forming processes like extrusion, forging, rolling, drawing, welding, etc. Okay. Now we have studied about inherent discontinuities. Inherent discontinuities means that while making the workpiece like casting, if some kind of discontinuities occurred, these are called as inherent discontinuities. These are primary processing means during the processes after making the part, after casting you can say. So this group refers to discontinuities that originate during hot or cold forming processes. The processes like extrusion and forging, rolling, drawing, welding, etc. Okay, welding is joining of two parts. Drawing is from a particular die you try to draw. Rolling is the bars. Forging is you heat a workpiece to a particular temperature and then uh, put the impact with the help of a hammer to draw the new shape. Extrusion is also like that. So like you heat up the material and pass with the die so that the required output will be in the shape. The workpiece will become in the required shape. So inherent discontinuities in the material could propagate and become significant also. Like if due to some reason some inherent properties are already there, so that also could contribute to primary processing discontinuities. So we should try to avoid inherent discontinuities at the primary stage also and these continuities also. But we should know that what all sorts of discontinuities that occur. Like seams. Seams are elongated surface discontinuities that occur in bars during rolling or drawing process. During rolling or drawing process. You have seen this diagram on the right hand side. It is showing a circular something like bar, like a roll, and on the upper and the bottom side there are curves going on it. Right? There is a discontinuity on the upper side and on the bottom side. On the upper diagram, right hand upper diagram. So what is this? These are kind of a surface discontinuity. Okay, that is occurring in the rolling or drawing operation in the bars. Okay, maybe due to less amount of material available or metal available. Okay, now they result due to underfilled areas that are closed shut during rolling process. Now this is due to the negligence of the worker. If the worker is not aware of the various you can say do's and don'ts while operating the rolling process or rolling passes, then this kind of issues occur. What they do that they try to shut it before or close shut the working, and what happens that due to some reason some underfilled areas they remain, And when you start the new process, automatically these kind of earlier things come next. They come in the coming passes. So those underfilled areas may result because of blowholes or cracks in the material. See, blowholes or cracks, you all know that during these are also inherent discontinuities. Like suppose if you are doing casting and due to cast and when you are pouring the molten metal inside the cavity, then due to the temperature difference between the molten metal and the cavity and the surface, there is some kind of gases are evolved which may lead to porosity or blowholes in the casting only. So it will be shown in the workpiece. So if that problem is there in the starting only, so this also may lead to seams because there is insufficient material. The gases have taken the space. So when you will heat up a little, the material will be less available. So this due to this also these seams may take place. Also seams may also result from the use of faulty, bad lubricated or oversized dyes. If the worker is not doing their task properly, then you can show such kind of faults or unlubricated things will occur. And suppose if you are using oversized dye which is not required, then also see, if something is oversized and you are putting inside some less kind of quantity, then automatically it will lead to some kind of error. Here it will go to primary discontinuity named as seams due to the usage of oversized die. You can see in the right hand side bottom diagram, it is showing that seam in finished bar when underfilled is squeezed tight on the subsequent pass. And while squeezing also this kind of error may occur. A small discontinuity can cause how much effect on the workpiece. Okay, so this should be well detected at the elementary stage only. Okay, lamination. Lamination are thin, flat subsurface separations that are parallel to the surface of the piece. See, as the name says, lamination. Lamination, you understand that something on the surface, okay, it may be a layer or a sub-layer or a subsurface. Okay, so they are saying that if they may result from inherent discontinuities like pipe inclusions, porosity. Porosity, I just told you that what is porosity. That are flattened during the loading process. See, I tell you, pipe is when you are pouring a material, a molten metal inside a cavity, then what happens that if you pour insufficient material, then what happens that it will form a pipe. Suppose something is unfilled, okay, something is unfilled at the center. It may form a V shape or a U shape, depends on the die and the positions and the angle and their operating conditions. Inclusions I told you earlier also, and porosity I told you in the previous slide also. Blowholes and porosity. So if we are using made a workpiece and if we are trying to flatten that workpiece during the rolling process, what happens that these due to these discontinuities, it will create flat subsurfaces. That means that there are surfaces that are separated. It will look like separated surfaces. So it will show like some laminations is there. A lamination is a kind of a primary processing discontinuity because you are processing, you are flattening the pipes, okay, during the rolling process. So at that point, if this kind of error shows, it is also a kind of a discontinuity. Stringers. Stringers are elongated subsurface discontinuity that are found in the bars. The same way, if you are trying to flatten a bar, then it will show some kind of surfaces, but they are elongated. They are not layered. They are this shows some elongation is there in the surface. It will. or if you try to stretch the bar, then also this kind of issues they come. It is seen there on the, yeah, on the workpiece. Okay, cupping. As the name says, cupping is a kind of a subsurface discontinuity that may have occurred in bars during extrusion or severe cold drawing. Like suppose if you are trying to draw something from the, you can say, during the drawing process, like cold drawing, or you extruding something in a, like a bar, you are extruding a bar. So what happens that during extrusion, they have it, the whole material divided into two, you can say, layers. One is the upper or the exterior, and the second is the interior portion. What happens that the upper portion is coming, and the interior of the material, it doesn't flow relative to the upper surface. Okay, so what happens that the interior of the material is not flowing as fast as the surface, okay, the exterior surface, which lead to stress. And if the stress is building up, then automatically after some time it may lead to a rupture, which can be seen as a cupping. Cupping means something uh, in between is in interior, something is missing. Cupping. Okay. Normally, if you try to go in cold drawing or extrusion process, then this kind of error it is found. Okay. Now, cooling cracks. Cupping is very from क्या बोलूं, this discontinuity may be found during cold drawing process because you are not heating up the workpiece. You are not uh, providing heat to the workpiece. You are just trying to coldly draw and get the new shape. So this issues occur. Cooling cracks may occur on the surface or bars after rolling operation due to stress developed by uneven cooling. See, what happens that after rolling operations, what happens, we try in the starting we have given some heat, but what happens that due to successive movement or due to successive production operations, if we are not giving the material enough time to cool, then cracks occur on the surface. Why? Because the upper surface is heating, is getting cool, but the inner is not getting cool at the same time. It needs some time. So what happens that if again uneven, if the inner surface is not cool, then again we'll go with the another operation. Automatically, it will. What happens that the cooling cracks will occur on the bar. Okay. Now forging and rolling laps, very important, and you can say you will. These are most commonly found discontinuities. Like laps are elongated surface discontinuities that occur during rolling or forging operations due to the presence of some excessive material film that is folded over. Seems it was having less material, that discontinuity. Laps have excessive material. Okay, excessive material. So excessive material is shown that is coming out due to squeezing process in the rolling. What happens that if there is some excess of material, then it is shown as fin. Okay, and somehow it is shown that a kind of a folding, extra folding is there on the material or on the workpiece. Okay, and this problem may occur because if you have oversized blanks. So what happens that you use extra material due to oversizing, and when you go for actual operations, these laps occur. Extra material is shown like in the form of defects, discontinuities. Or secondly, if you are not handling properly the dies, or you can say the not handling properly the material in the die, Then what happens? Then due to some technical issues, these kind of discontinuities they can occur. Like in the bottom diagram, you can see there's those laps that were shown in the upper diagram. These are somehow folded over, and like due to folding, what happens that it is forced inside the workpiece in the workpiece. So what happens due to the forcing inside? There are some discontinuity that happens inside the workpiece also. You can see the lining from which it is getting inside the workpiece. Okay, so this lapping issue, if not properly checked, it will also lead to a kind of a discontinuity, which is you can say that if if some circular motion is there, then this workpiece will create some issues. Okay, then internal burst or external burst. Internal bursts are found in the bars and forging formed at excessive temperatures due to presence of inherent discontinuities that are developed, that are pulled apart by tensile force developed during the forming operation. As the name says, internal burst. Okay. Now, what happens that if you have due to some inherent discontinuities like porosity or blowholes or some kind of cracks are there in the starting, then what happens if you try to you can say apply some tensile force or pulling force, then at that time some kind of internal burst it may occur inside the workpiece. An external buckson means that it uh, occurs when the forming section is too severe or the sections are thin. Matlab, it's very simple to understand. If something internal is there, something happened on the internal of the workpiece due to providing excess temperature. Excess temperature, what happens? The internal, if there some cavity, it releases very easily. So what happens that due to the removal of the gases, then this kind, and you're applying force also for pulling apart. So at that time, what happens that it may lead to some internal burst. And external burst, obviously, as you can understand, if the sections are thin and still in thin sections, some kind of blowholes are there inside, like as a inherent discontinuity, then also it may break down. Okay, so these kind of issues are also a part of primary processing discontinuity. Slugs. You can see in the diagram which is showing a slug. Slug are surface discontinuities found on the inner surface of the seamless extruded tubes. They occur when some metallic pieces that are stuck on the mandrel are torn and fused back on the inner surface of the tube. Because while you are trying to draw the workpiece, what happens that if due to some mistake some metallic piece is struck on the mandrel, okay, then also these kind of issues there. Okay, you see in the diagram it's clearly visible. Gouging. You can see in the diagram also it is properly visible that what happens a kind of a tearing is taking on the surface. Okay, so you can easily say that gouging is the surface tearing found on the inner surface of seamless tubes, and it is caused by that material is not free to flow between the mandrel and the inner surface of the tube. Due to this reason, what happens? The surface tearing happens on the inner surface of the extruded tube. Okay, and this lead to a discontinuity named as gouging. It is clearly visible. You can see it very clearly. It is clearly visible. Okay. Hydrogen flakes. Hydrogen is available during manufacturing processes nowadays. Uniform decomposition of water vapor to or hydrocarbons, oil or atmosphere. And it dissolves in material at temperatures above 200 degrees centigrade. So what happens that nowadays the manufacturing processes are going with this also. So hydrogen flakes are thin subsurface discontinuities that develop during cooling of large size parts produced by forging or rolling because of the entrampment of hydrogen resulting from rapid. Now, what happens in this that during the you can say cooling of some large parts which you have produced by primary processing, like you can say extrusion or forging or rolling. And what happens that if some hydrogen is trapped, then it leads to hydrogen flakes. After the process, if some hydrogen is trapped inside, okay, and cooling happens at that time, then what happens? Some error is called as the trapped hydrogen workpiece has some discontinuity, and that discontinuity is called as hydrogen flakes. Now we'll go with the welding discontinuities. Welding discontinuities are very interesting. You can see that these discontinuities you might have studied in your maybe first year in workshop, or maybe in the third or fourth semester in the manufacturing technology or manufacturing science and technology, whatever subject is there. So welding technology discontinuities, these are several type of discontinuities that result from welding operation. Only the discontinuities associated with fusion welding processes like arc welding, gas welding. So here only I have discussed about the discontinuities that have occurred due to these two reasons, arc and gas welding. Because welding is a very vast process, one of the commonly used permanent joint process. So it has tremendous amount of data and post and pre-processing articles. Uh, so discussing all of them is not possible. So two of the most common weldings that are used, gas and arc welding, these the problems or discontinuities caused due to these two welding processes. These are presented here for understanding. The first is cold crack. The name says cold crack. That means that also known as delayed cracks or are hydrogen induced surface or subsurface cracks that appear in the heat affected zone or the weld metal during cooling or after a period of time. Okay, these are, you can say, as the name says, cold cracks. Something happened after a certain time. So it can call as delayed cracks. Okay, and it normally appear near the heat affected zone or in the heat affected zone or where the welding has been done. But these cracks are visible only, you can say, cooling of the welded area has been done. Okay, it is not seen in the starting, it is seen after a particular time has had taken after the welding. The source of hydrogen which leads to this type of cracks may include moisture in the electrode shield, the shielding gas, or the base metal surface, or contamination of the base metal with hydrocarbon, oil or grease. See, these kind of normally problems occur when the base material is either having a layer of oil or grease, so it may lead to such kind of cold cracks, or some kind of, you can say, moisture is there in the electrode shielding. So these kinds of cracks may occur. Okay, it may occur. It is not sure कि it will not occur. It may occur. Okay. Secondly, hot cracks. See, whatever discontinuities you are discussing, if some skilled worker is doing those things, then only inspection can be done very easily. Then hot cracks, including several types of cracks that occur at elevated temperatures in the weld metal. Those who are cold cracks, these are hot cracks. So as the name says that these cracks appear in the at high temperatures or the temperature when the material is in heat affected zone. In general, hot cracks are usually associated with steels having high sulfur content. Okay, you will understand that hot cracks, they can be made only at elevated temperatures in the weld metal or where there is heat affected zone. And secondly, the all hot cracks are having associated with steels. Okay, all hot cracks are usually associated with steels. having high sulfur content. The common types are like solidification cracks. It means that like one more thing that I want to tell you, then while making or sorry, while heating the material and doing some kind of you can say any kind of work on the workpiece, okay, or you can say welding, you can say that if proper uh, cooling is there, proper channel of cooling is there, then this problem will not occur. But if during cooling they have high sulfur content at the time of joining, then these kind of cracks occur. Okay, this type, the first type, the solidification cracks. This type occurs near the solidification of temperature of the weld metal. Remember that this occurs near the solidification temperature of the weld metal. When it is getting solidified, this type of occurs because some kind of sulfur is there. Then they are caused by the presence of low melting point constituents such as iron sulfide that segregate during solidization, other than the shrinkage of the solidified material causes crack to open up. That means that if during cooling process we are using a low melting point material which is having sulfides in it, and you can say a kind of shrinkage takes place while cooling, then also what happens that these kind of cracks occur due to shrinkage, and it may lead to you can say a discontinuity, right? Then go for the centerline cracks. It is shown in the diagram only. The centerline crack is a longitudinal crack along the center line of the weld bed. It occurs because the low melting point impurities move to the center of the weld pool as the solidification process from the weld toe to the center. Then the shrinkage stress of the solidified material causes cracking along the center line. Very simple to understand that as the name says, centerline cracking means it is a kind of a longitudinal crack, and it happens when you have means the impurities which are having low melting point, they move towards the welding zone as soon as the welding happens, and they cause discontinuity called as center line. So the likeliness of centerline cracking increases when the travel speed is high or the depth or to width ratio is high. See, it normally is not acceptable. This kind of something actually not acceptable. Okay, because what happens that if proper welding style is not there, then these cracks will occur, and these cracks will somehow affect the working. Like suppose if you are joining two railway tracks, है ना? If you are joining two railway tracks, so what happens that while joining the railway tracks and such kind of error occurs during welding, then you can understand what can be the effect because the trains run at a very high speed. So we have to be do our work with patience. Not that welding speed should not be too high. It should not be too low. So that proper you can say welding can be done. And if any kind of you can say issue is there, it can be resolved then and there only. Theater crack, very easy to understand. As shown in the diagram, it is showing that weld crater. There is welding is already done on the workpiece, but still at the welding zone there is some kind of a crater. Okay, and a crack shown is that crater, which occurs in the crater formed at the termination of the weld pass. Crater cracks are mostly star shaped. Okay, it is a checkpoint. It is not a center line. At the welded zone, there is a kind of a star point. Okay, or you can say a star shape, and they are caused by three-dimensional circular lines. Oh, obviously it says that when it is going to a star shape, man, it is not able to shrink from all directions, then only such kind of crack occurs. The activity of cracker increases when the welding is terminated suddenly. Means what happens is that you are doing a welding. Don't try to overdo it, or don't try to fastly do it. Just do it with proper pace so that each and every you can say step is done correctly. Okay, so this is kind of a cater crack. Cater means normally starch kind of a crack they appear on the welded bone. Liquidation cracks, you all know that is also known as hot tearing, occurs in the heat affected zone when the temperature in that region reaches to a melting point, then the temperature of low melting point, constituents causing them to liquidate and segregate at gain boundaries. Very easy to understand that if you are working and you can say temperature in the particular region reaches to a melting temperature of low melting point constituents. So at that time you can say that some act, activity takes place. As the weld cools down, shrinkage stress causes the formation of small microscale cracks, which later might be due to applied stresses to form a continuous surface of a surface crack. See, in the first part, it was showing that uh, the you can say the low melting constituents they liquidate because they have low melting point. They liquidate and segregate at the weld at the grain boundaries. Okay, segregate at grain boundaries. Yes, and causes the and during cooling. Okay, what happens that there are small cracks that are made while cooling. Okay, and this you can say if later found out, then also it may lead and if you apply some stress, then also it may lead to subsurface crack. Laminar tearing. Laminar tearing is the subsurface discontinuity that occurs in roller plates having high content of metallic inclusions. Okay, like you can see in the diagram only on the right hand side. Okay, then what happens there? There is the you can say you can say if there is some inclusion, like you are working on a metal and if there is some non-metallic inclusion, then you can easily see that how it is weakening the strength and disturbing the process. So what kind of laminar tearing will help? These inclusions will have low strength and they are flattened during rolling. Thus they can be torn underneath the welds because of the shrinkage stress in the through thickness direction. What happens that after a particular time they can torn each other. They can be torn. Okay. So, beneath the welds only. The black zone is welding, and the line that is shown on the upper and bottom diagram, uh, that is like horizontal line and one vertical line. This is all called as laminar tearing. So this may also lead to you can say turning also. Okay, so this is like uh, serious issue. Now lack of fusion. Lack of fusion means you know that in the welding fusion happens where the workpiece and the welding electrode they come to, nearby and the arc happens. At that time, the base metal also melts to some extent and the filler material also melts and gets filled on the welding zone and fuses with the base metal. The lack of fusion is the failure of filler material to fuse with the adjacent base metal. Okay, or the weld metal from previous pass, that is from inherent discontinuity. Now, because the surface of the base metal did not reach to the melting temperature during welding. Like when you are doing welding, what happens there sometimes the proper fusing of the base metal and the workpiece is not there. So if proper fusing is not there, then what happens? Then what can be done? Then the welding will get disturbed. So lack of fusion. Lack of fusion means the fusion didn't took place. The melting of the base metal and the filler material. They did not patch up easily. They did not match up easily. So this typically occurs when the when large component that could dissipate heat during, especially when it is relatively low temperature before welding. Welding, sorry. So, like we can say that in the large components, this uh, what happens that uh, this kind of fusion is less strong, whereas compared to the season energy, the materials which have low temperature, in that cases, this kind of lack of fusion cases they are more firm. Okay, and the lack of fusion is often seen at the beginning of the first pass. In such cases, it is commonly called as a cold start. Yet this you all know that while welding, the cold start is a very form of manner. Also, lack of fusion could occur when the surface previous pass is not allowed clean, and from slag, where slag reduces the heating to the underlying surface. Okay, so this is a kind of a discontinuity named as lack of fusion. Lack of penetration. Now, penetration, you all know that you are filling something in a open space. You are penetrating something. So lack of penetration is insufficient, less than specified penetration of the weld metal into the roots of the joint. This is mostly caused by the improper welding parameters such as low amperage, oversized structure, or improper angle or high travel speed or inadequate surface pre-cleaning. See here also high travel speed is creating an issue in the previous year or for discontinuity also high travel of welding was avoided. So what happens that if you supply insufficient filler material at the welding zone, then what happens that the penetration is not complete or not adequate. It is there is some lack of penetration. Okay, so at that point it is called as lack of penetration. Okay, now next porosity. I told you earlier also. It is kind of a small cavities of both which is mostly have spherical shape that are bottom surface of the weld or slightly below the surface. Now this occurs when some you can say uh, constituents of the molten metal they vaporize, causing small gas pockets that gets entrapped in the metal as it solidifies. I told you earlier also that it is trapped. Gases evolve due to contact between uh, material, you can say molten metal and the cavity. So some kind of gases are evolved that are trapped. Okay, and this leads to porosity. These small bores could have a variety of shapes, but mostly they are they have a spherical shape. Okay. Now the distribution of bores in weld metals could be linear porosity and they could be clustered together. So we can say that in general the porosity can result from the presence of uh, dirt, dust, or moisture on the surface of the base or filler metal. Also could result from high sulfur content in the base metal or excessive length arc. See, these are the various things that told that okay, porosity can occur from time to time, or you can say due to the presence of dirt, rust, or moisture. Okay, at the in the filler material, then also it occurs, and if there is some high sulfur content, then also it occurs. Okay, so this discontinuity should be found out, and it is commonly find out. It is commonly found out, so you can easily understand. Then inclusions we refer to the presence of some material that is not supposed to be present in the weld metal, extra material. Okay, like slag inclusion, you have unrequired slag at the welding zone. You can say this type of inclusion mostly happens in the shielded metal arc welding, and it occurs when the melt acids surface of the molten metal and gets trapped in the weld metal during solidification. Matlab, there is something You can say like the slag cannot float to the surface of the molten metal. While pouring the molten metal, the earlier inclusion metal is not able to get removed. So what they do that when you pour the molten metal and after cooling it is showing that uh, this whole inclusions are trapped in the weld metal during solidfication. This could happen when the solidfication rate is high because you are fasting in cooling and the weld pool porosity is high. Okay, this kind is also an oversized electrode is used or slag on the previous pass was not properly removed. Okay, like you can you say that in the previously whatever work was done inside that, then if proper unwanted material like slag was not properly removed, then also if you are cooling faster, then also such kind of inclusions happen. Tungsten inclusion, as the name says, tungsten. This type of inclusion can be found in weld metal deposited by gas tungsten arc welding as a result of allowing the tungsten electrode to come in contact with the molten. Okay, so here you can use that tungsten electrode comes in contact with the molten metal. Oxidation inclusions, very simple to understand. It has a you can say this type of inclusion results from presence of high melting point oxides on the base metal which mixes with the molten metal during welding. Okay, now it's very easy to understand. You can see in the diagram also that how such oxides inclusions they discuss. Inclusion I told you earlier also that, but here oxygen you can say on the this. Sorry, with the presence of high metal oxides on the base metal. Okay, which mixes with the molten material during welding. This is okay. Then undercut, as shown in the diagram, undercut means reduction in the base metal thickness at the welded toe. The base metal, purple metal, there is a reduction in the, you can say, base metal thickness. So such kind of error occurs. This is caused by oversized molten weld pool, which may result from excessive amperage or oversized electrode. Okay. Now second is overlap. Like you see undercut, there is overlap also. There is a protrusion of the welded metal over the die toe due to lack of fusion. Due to some problem, the proper filler material and the base metal fusion doesn't happen, and they give you a problem of overlap. This may cause by insufficient amperage or travel speed. Right. Now secondary processing discontinuities. Now what happens that these secondary discontinuities they refer to the original during grinding or machining, heat treating, plating. Okay. I'll discuss these discontinuities in the next lecture because I will discuss MCQs also with you. So I will start away first of all going with the MCQs faster. Uh, like this, the first MCQ that blowholes are caused by gases released from the mold itself. You all know that I explained you this whole query that how this has happened during casting process. This is true. The second, that these are usually oxide, sulfide, or silicate that remain with the molten metal during original casting. Here also you can understand I told you about non-metallic inclusions or pipe or hot tears or blowholes ability. So here this is the answer is non-metallic or slag inclusions. Now here it is showing that what is our seams. These are elongated surface discontinuities that occur in the bars during rolling or drawing operation. They result due to underfilled areas that are closed shut during the rolling process. I told you earlier about this in the starting only. Okay, these are seams. Then seams may result from the use of faulty poorly or oversized dies. Right, because the lubrication is not good and the size are over, then also the seams issues they occur. Uh, yeah, seams. Then fifth one, these are elongated subsurface deformities that are found in bars. They run in the axial direction. They result from the flattening and lightening of non-metallic inclusion during the rolling process. So here I told you and I explained you in the starting only that these are called as stringers. Okay, subsurface discontinuities. Okay, then next question. These are elongated subsurface discontinuities that occur during the rolling or forging operations due to the presence of some excessive material fin that is folded over. That is folded over during rolling operation. Laps. Okay, excessive material was there that was found, and if you process further, then what it do? It folds over the workpiece, leading to some lapse, the kind of a discontinuity. Then next question: these are found in bars or forging formed at excessive temperature due to presence of inherent discontinuity that are pulled apart by a tensile force developed during the forming operation. Remember presence of inherent discontinuities that are pulled apart. You heat the material and you just you can say are stretching it. Then at that time that kind of issues come. It is called as internal burst. Remember? Okay. That is a surface tearing found on the inner surface of the seamless extruded tubes. Remember, same I taught you. And it is caused at excessive friction between the mandrel and the inner surface of the tube. Gouging. I shown the diagram also. Some space, some vacant space. Okay, it has happened due to the friction between mandrel and the inner surface of the tube. The next question, these are also known as delayed cracks, are hydrogen-induced surface or subsurface cracks that appear in the heat-affected zone or the welded metal during cooling or after a period of time, like some days or some hours, you can say. So I told you also that it uh, like it is kind of a cold crack. Okay. Now next question. It is a longitudinal crack along the center line of the weld bed. It occurs because the low melting point impurities move to the center of the weld pool as the solidification progresses from the weld to the center. Remember, very easy to answer. Then shrinkage stresses of the solidified material causes cracking along the center line. Name the same name says center line crack. So whatever questions we did in MCQ, we all studied them in our lecture. So you can relate to them very easily. And these are some references that we should discuss. Sorry, you should refer and will be helpful to you in getting more knowledge in this subject. So I thank you all for listening to me. Thank you.